In this tutorial, we're going to take a look at a number of examples, 10 to be exact, of linear relations questions. And this is the main purpose of this video, this tutorial, is as a practice for the grade 9 mathematics EQAO test in the province of Ontario, Canada. People from other parts of the world may certainly benefit from these, but this was exactly why this video, and I will be making 4 others up. 3 are done, I get 2 left to do. So a linear relation is a relation where 2 variables are related by a multiplying factor, in which it's called a direct variation, or a multiplying factor plus or minus some fixed value, and that's called a partial variation. And linear relations, if you look at a table of values, have first differences that are all the same. So here's a linear relation, and notice that the x's are going up by 1. In order to tell what we're doing here, it's most convenient they go up by the same amount, although there are ways to do it if they don't. But they don't always have to go up by 1. They could go up by 2 or 5, or as long as they're going up the same thing, it's okay. So look at now once you identify that the x variable, or whatever's on the left, is going up by 1, look at the changes in y. So from 15 to 13, it's going down by 2. From 13 to 11, it's going down by 2. Now, to get those differences, you don't put in your calculator 15 minus 13, because we want the change from 15 to 13. So 13 subtract 15 is the negative 2. 11 minus 13 is negative 2, not the other way around. So 9 minus 11 is the difference from 11 down to 9. It's going down by 2. So those differences, and I'm going to do one more, they're all negative 2. And of course, negative 2 here, negative 2 here too. I didn't bother to do those. Now, as long as these are going up by 1, that is the rate of change for this relation, or the slope. And so if you're using y equals mx plus b, then the slope would be negative 2. And so the only thing we need to find now to know the entire equation relating x and y here is the b value, which is called the y-intercept. And so I can take any of these xy pairs or ordered pairs and substitute to find b. And in fact, I'm going to show you 2 different ways to do this. If you know the y value when x is 0, this actually tells you that 11 is the y-intercept. So the equation is y equals negative 2x plus 11. Now, you won't always have the luxury of knowing what y is when x is 0. You know, if the table started here and just included these last 4 ordered pairs, then you wouldn't have the 0, 11. So what you can do is take one of the ordered pairs. So I'm going to use the 3, 5 point. This is x is 3, y is 5, so it's the point 3, 5. And I'm going to substitute, well, I'll look at this equation. I'm going to put 5 in place of y, and that 3 in place of x here. And so if we multiply the negative 2 by the 3, you get negative 6. So 5 equals negative 6 plus b, and I want to find what b is. So I'm going to take that 6 over here and add it to the 5 to get the fact that b is 11. So there's the same 11, and the equation is still y equals negative 2x plus 11. Now, if you didn't have this whole nice table that goes one after another with all these x's, okay, if you only had, for example, let's say a negative 2, 15, and the 4, 3, and you got 2 ordered pairs, you want to find the equational line between them. Another way to find the slope, the negative 2, the rate, is to use the slope formula. And so especially if you had maybe that point and another one in the middle and maybe the 4, 3 or something like that, use any 2 ordered pairs and substitute in place of x and y to find, x2, x1, y2, y1. So remember the subscripts here are just, it talks about the first point. So this is the first point, that's the second point. So I'm going to use the negative 2, 15 and 4, 3 here. And so I'm going to call this my x1, y1 point. So that's the first point. And I'm going to use the negative 2, 15 as the x2, that's supposed to be an x there, y2 values. So let's get rid of the slope formula here and substitute the values in. So 15 and 3 are the 2 y values we subtract in the top, y2 minus y1, over x2 minus x1. So x2 minus x1 would be the -2 number minus the 4 number. So that's where those come from. Now, if you decide to make this the second point and that the first point, the only difference is it'll be 3 minus 15 on top, and then it'll be 4 minus -2 in the bottom. The signs of both are just the opposite, so you will end up getting exactly the same slope. So 15 minus 3 is 12, and we subtract those x-coordinates. It was -2 minus 4 is -6, and that divides to give you -2. So once again, we get a slope of -2. So that's how you can use the slope formula to get that slope. Example 1 over here, we're asked to graph y equals 4/3 x plus 2. Now the 2 here is the y-intercept. So b would be 2, and the 4/3 is the slope. And so we start with the 2 here. It's kind of like the starting point. So that tells us that the line goes through the y-axis at 2 here. So I would put a dot there at 2 on the y-axis. Y-axis, not x. It's the y-intercept. Y-axis vertically, x-axis horizontally. And the slope is 4/3. So if you start at that point, and remember 4/3 is rise, the slope is rise over run. So if we start at this point and go up 4, and then to the right 3, that's another point on the graph. If we go up another 4, and then to the right 3, that's another point on the graph right there. Now, you can also go in the opposite direction. We can think of this, like if I multiply top and bottom here by -1, you can also think that as -4 over -3. So for example, if I started here and I went down 4, and then to the left 3, then that's another point on the line. And so I'll get lots of points now. I can draw my line through them. That's what y equals 4/3 x plus 2 would look like. And good idea to label lines with their equation, especially when you're putting more than one on an axis. So flipping over to the second page, we're asked to graph 3x plus 2y minus 18 equals 0. And so one way to graph this is to rearrange the equation and put it in y equals mx plus b form. That's one way to do this. So to put it in y equals mx plus b form means we're going to isolate the y term. So the first thing I would do is I'm going to leave the 2y term on the left and bring the 3x and the -18 over to the right. Or some people will say it this way: you're going to subtract 3x from both sides and add 18 to both sides, doing the opposite of those. So we would get 2y equals -3x plus 18, and I want to isolate for y. I'm solving for y here, so I'll divide out the 2, and so those divide out, and y equals -3/2 x. 18 divided by 2 is 9, so plus 9. So the slope is the -3/2, and you can think of it as -3 over 2 or 3 over -2. You can either put that negative on top or on bottom, but they're not both. It's not -3 over -2. Only one of those numbers is negative, or the whole fraction is negative, one or the other. See, the reason I know they're not both negative is if we had a negative on top and a negative on bottom, like if I put a negative here, -3 divided by -2 would be a positive, but the slope is supposed to be negative. So the y-intercept is 9, so we'll put a dot up here at 9 in the y-axis right there. And so now I can use either of these to find other points using the slope. So the -3 over 2, I would go down 3 and then to the right 2, so that's a point on the line. I could go down 3 and then to the right 2, and that's another point in the line. I could also, if I wanted to use this one, if my graph was higher, I could go from this point, or any point, up 3 and then to the left 2, and I'll get other points. For example, from here, up 3 to the left 2 is that point. So I've got lots of points here now. I get 3 points, so I can draw my line through them. And of course, remember, good idea to put the equation beside the line. So that's the graph for number 2. Another way to graph these is using intercepts. You can find the x and y intercepts by substituting 0 in place of variables. So if I want the x-intercept, and this is what it would look like, then let's say I'll do it over here and then erase that. So for example, the x-intercept looks like this. To find the x-intercept, we're going to put 0 in place of y here. So we would write we would write 3x plus 2 times 0 minus 18 equals 0 and solve for x. Now, this of course is 0, so, and I'm going to take the 18 over here. So I would get 3x equals 18 and then divide out the 3. So the x-intercept is positive 6. And you can't quite see that. Actually, the axis went out a little further here. See, that's 4. This would be 5. So there's the x-intercept at 6, like if we kept the line going down here a little bit. To find the y-intercept, well, actually, I already have it from the equation there, but just using the equation, you put 0 in place of x. So in this case, I'd be putting 0 up here in place of x. So we would go 3 times 0, so that first part is going to be 0, plus the 2y. And let's take the 18 over right away. So that's gone. So if I want to divide by 2 here just to isolate for y. And so I get y equals 9. So the y-intercept is at 9, which of course is this point right here. So once I have that point and this point down here, I could draw my line through them like that. So that's another way to graph the line. Let's get rid of all my markings here. Okay, so example number 3, you're asked to graph y equals 3 and x plus 2 equals 0. These are two special lines because they're either horizontal or vertical. And if you forget which is which, well, y equals 3 is the collection of all the points that have a y coordinate of 3. So for example, that's the point 2, 3. And I'm going to plot a few points that, see, that point there is the point 5, 3. And here comes another one, that point right there is the point -1, 3. So notice that there are 3 different points that all have a y value of 3. The equation of the line y equals 3 is just a collection of all the points that have y coordinates of 3. And so that's the horizontal line through 3 on the y-axis. Those all have y coordinates of 3. You can also think of that as the line, because it's perfectly horizontal, it has a slope of 0. So if you use y equals mx plus b, it's y equals 0x plus 3. So the y-intercept is 3 and has a slope of 0, meaning it's horizontal. It doesn't rise or fall at all. Now, x plus 2 equals 0. Let's isolate for x. So we'll bring the 2 over, so x would equal -2. And so x equals -2 is the collection of all the points that have x coordinates of -2. So I'm going to plot a couple points here. So for example, that point right there has an x coordinate of -2. It's -2, 5. This point down here has an x coordinate of -2. It's the point -2, 3. So notice they both have an x coordinate of -2. See, all the points on this line have x coordinates of -2. That's -2, 1, -2, 2, -2, 4, -2, -2. All have x coordinates of -2. So x equals a number is the a vertical line through -2 on the x-axis. That's the only kind of line that can't be written in y equals mx plus b form because there is no y to solve for. So you have to just remember that it's a vertical line through -2 on the x. Example number 4 here, we're asked to find the equation of the line passing through the point 3, -5 and with an x-intercept of 6. Well, that's the one point we're given. If the x-intercept is at 6, like this point was over here, the coordinates of that point would be 6, 0. So even though you're not told it explicitly, that would actually be the point 6, 0, because it was on the x-axis of the y value would be 0. So we could use the slope formula, and we'll get rid of that writing, to find the slope of the line through these 2 points. So I'm going to think of this as my x2, y2 point and x1, y1. So for the y2 minus y1, we would go 0 minus -5, and x2 minus x1 would be 6 minus 3 in the bottom. So 0 minus 5 is the same, 0 minus -5 is the same as 0 plus 5, which is 5, and 6 minus 3 is 3. So that's my slope. So in y equals mx plus b form, it would be y equals 5/3 x plus b. And so now I need to find the y-intercept. And I'm going to use a point to find that. And so I'm going to substitute the 3, -5 point in. So -5 is the y. So I'm going to put -5 here, and 3 is the x. I could have used the 6, 0, wouldn't matter. It'll give you the same y-intercept. So I just chose the first point. And so 3 is the same here as 3/1. So if you multiply 5/3 by 3/1, 5 times 3 is 15, and 3 times 1 is 3 on the bottom. So that would actually be 15/3, and that divides evenly. So 15 divided by 3 is 5, so we really just have -5 equals 5 plus b. Some people will show you, this is another way to simplify this. I could just divide this into this, and so 5/1, or 5 divided by 1, is 5. That's another way to get that. So I want to isolate for b, so we'll take this 5 over here and subtract it from the -5. -5 minus -5 is 10, -10, sorry. And so the equation, so b is -10, so we're going to put -10 here, and so that's the equation of that line, by equals 5/3 x minus 10. In example number 5, we're told that Arnold buys a prepaid phone card, and after he's used it for 20 minutes, there's $57 left on the card. And after you use it for 45 minutes, the value is down to $53.25. So we're asked to find an equation that relates the value remaining and the time left on the card, or the time the card, has been used. So I made a little table here, time, so this is the amount of time it's been used and the value that goes with each one. So the first thing, this would be a linear relation because he's paying the same amount per minute each time. The rate of change is the amount he's paying per minute. So I'm going to find the difference between the values here from $57 down to $53.25. So in my calculator, I would punch in $53.25 minus 57, and the change is $3.75. So he paid $3.75 to talk for this 25 minutes. From 20 to 45 would be a time of 25 minutes. Now, remember, rate or slope. Slope is rise over run, which is the change in the dependent variable divided by the change in the independent variable. So if we divide this -375 by 25, we'll get the rate of change. So that works out to -0.15, which means he's paying 15 cents, because it's negative, 15 cents per minute. So that's the rate of change of this equation. Now, I'm going to use y equals mx plus b because we use that to model linear relations a lot. Now, instead of y, I'm calling it v, and instead of x, I'm calling it t for time. So I'm going to just substitute those in. So y isn't y, it's v, and x is actually t, so that's time, that's the value left. And so my rate is -0.15, so this is -0.15. So that's my equation. I just need to find the b value, which would be the initial value. This is a partial variation. The initial value is what Arnold paid for the card, actually. And so we take one of these points here. I'm going to use the 20, 57 one. So 57 is going to go in place of the value and 20 in place of the time. And so I'm going to solve for b here. So the first thing I'm going to do is multiply -0.15 by 20. So that gives me -3. And so to find b, I would take this -3, or isolate for b, and bring it over here and add it to the 57. So 57 plus 3 is b, so b is 60. So he paid $60 for his card. So the equation that relates the value remaining to the time used would be, and so I'm putting the 60 in place of b here. So the value is -0.15 times the time plus 60. So that's the equation that relates the value to the time the card's been used. In example number 6 here, we're going to talk about linear and nonlinear equations. So I have 5 examples of each here. So linear equations are, for example, y equals 4x. That's in the y equals mx plus b form. It's writing y as a multiple of x. It's 4 times x. This is called standard form. Notice that each variable is just multiplied by some constant, like 3 or -2, and there's something added to it. That's okay. That's still a linear equation. This is actually in y equals mx plus b form. This is 2, although we're writing the x term at the end subtracted from the 12, but that would still be the y-intercept, and the slope would be -5. These are also linear equations. Remember, that's a vertical line through -3 on the x and a horizontal line through 2 on the y-axis. So those are examples of linear equations. Now here's 5 examples of nonlinear equations. The x is squared here, so that makes that not a linear equation. You can't have products of variables. X times y, that's nonlinear. That would be a curve, not a straight line. You can't have an x in a denominator, like the 2x here. So that would be a curve as well. If the x is in the exponent, that's an exponential equation, which is a curve, not a line. And the x can't be raised to any power besides 1. See, this is x to the first, x to the first, x to the first power, x to the first. But x is cubed here, so again, that's a curve, not a line. Example number 7, we're given this line, y equals 3/2 x plus b, and we're told it contains the point 4, 13, and we're asked to find the b value, which is the y-intercept. So I would take my 4, 13 point and substitute 13 in place of y, and 4 in place of x here, so we have 3/2 times 4, and solve for b. Now, if you multiply 3/2 by 4, it's really, 4 is the same as 4 over 1. So 3 times 4 is 12. And 2 times 1 is 2. And so that divides to give you 6. You can also do this. 2 goes into 4 twice. And so 3 times 2 again gives you 6. So there's a couple ways to get that. So that works out to 6. To isolate for b, I would take the 6 over and subtract it from the 13, which gives me a y-intercept of 7. So that's the value for b. Example 8, and there's 2 parts to this. A is on this page, b is on the next. We're asked to find the equation of a line parallel and passing through the point 3,8. So parallel to this line right here. Now, this equation up here, the 3/4 is the slope. So if the line I'm looking for is parallel to this, parallel means they have the same slope. So I'm going to again use y equals mx plus b, so my parallel line would have the same slope as this, so it would be y equals 3/4 x plus b. And the way we find the b is the same as what we did in 7 here. We're going to substitute this 0.38 in. See, if the line goes through 3,8, then 3,8 has to satisfy the equation, so that's how we can use it to find the b value. So 8 goes in place of y, 3 goes in place of x here, and so 3/4 times 3, 3 times 3 is 9. Remember, there's a denominator of 1 here, 1 times 4 is 4. And so this 8 here, now, I'm going to isolate for b, so I'm going to bring the 9/4 over, but this 8, I'm going to get rid of it and write it as 8 over 1. Before I bring the 9/4 over, I'm going to be subtracting that from the 8, so I want to get a common denominator. So I'm going to multiply the 8 top and bottom by 4 because there's a denominator of 4 here. So this will be 32 over 4 equals 9 over 4 plus b, and then to isolate for b, we'll take the 9/4 over and subtract it from the 32/4, which works out to 23/4. So that's the y-intercept. So my line, I can put 23/4 in place of b here. So this is my equation. It'd be y equals 3/4 x plus 23/4. Now that's the parallel question. On example 8 here, we're going to find the equation of a line that's perpendicular to this line and passes through this point. So the 3/4 is the slope of this line. Now, if we want a line with that's perpendicular to this, the perpendicular slope will be the negative reciprocal of this. So you flip it upside down and you change the sign. So the slope of this perpendicular line would be -4/3. Okay, flip it upside down, change the sign. If it's positive, make it negative. If this was negative, we would make it positive. And so I need to find the y-intercept. So I use this point that we're told is on the line. So 11 goes in place of y, 6 goes in place of x, 6 or 6 over 1. So if I multiply this out, negative 4 times 6 is negative 24, 3 times 1 is 3 in the bottom. And that actually divides out to give me negative 8. To isolate for b, we'll bring this over and add the 8 to the 11. And so b works out to be 19. And so putting 19 in place of b here, this is my equation. Y equals negative 4/3 x plus 19. Example number 9. We're told that this caterer uses the formula C equals 20n plus 300 to determine the cost. C is in cost and n represents the number of people for a banquet. And we're asked what's the minimum and maximum cost if the hall holds up to 200 people or they're having the event. That's the venue size. Fire marshal won't allow any more than 200 people in. Now the minimum cost would be when there's no people, when no people attend whatsoever. So we would take our equation and put 0 in place of n. So 20 times 0 plus 300, of course 20 times 0 is 0, so it's just 300. So the minimum cost would be $300. The maximum would be when the highest number of people attend. So we would put 200 in place of n in the formula. So it would be 20 times 200, which is 4,000, plus the 300, so it's 4,300. So that would be the maximum cost. Now a little bit more about the minimum. Of course, practically, nobody's going to pay the $300 because the caterer is not actually going to run a banquet if nobody shows up. They might actually have some minimum value. They might say, we're not going to cater unless there's, let's say at least 10 people. 10 people will do it. So if that was their stipulation, then you would put 10 in here. You would go 20 times 10 plus 300, and then that would be the minimum cost. Last example here, Todd starts walking from home to the corner store. He's at the corner store for a few minutes and then he goes back home. So the first question asks, at what rate does he walk to the store? So this would represent him being at home, and so along here is where he's walking to the store. So the rate that he walks to the store would really be the rate of change of this part of the graph, or the slope of this part of the graph. So rate in this case would be distance divided by time. So if we look at the entire journey from home up here to the store, to go from here to here, he's traveled 800 meters. Notice every block's 100, so that's 600, 700, that would be 800 there, in 8 minutes. So 800 divided by 8 is 100, so he's actually walking 100 meters per minute. So that's the rate or speed that he walks to the store. The second question asks, how long was Todd at the corner store? Well, this would be the part where he's at the corner store. So that's 8 minutes, 9, 10, 11. So he's there from 8 minutes to 11 minutes. See, his distance doesn't change in relation to home. So he's actually not moving away from home or going back towards home yet. So those are the 3 minutes that he was at the corner store. So he was there 3 minutes altogether. And C asks, how does his trip from the corner store back to his house differ from the first part when he walks to the store? Remember, this is going to the store, he's at the corner store, and then he's going back home. Well, let's calculate the rate of change along here. Notice it's steeper, so you should anticipate he's walking or moving faster. So he's gone the 800 meters, this is 800 meters, in only 1, 2, 3, 4 minutes. So he covered the same distance, but in 4 minutes instead of 8. So you divide 800 by 4, it's 200 meters per minute. Now, we don't usually talk about speeds in terms of meters per minute. It's often kilometers per hour, something like that. So, well, how fast exactly are these? One thing you can see is that 200 is double the 100, so here he's actually moving twice as fast as he is here. So, in order to get a better idea of how fast he's actually moving, if we take a look at the 800 meters in 8 minutes, 800 meters is 0.8 kilometers in 8 minutes. Now, if we want to convert this into kilometers per hour, which is something you might understand better, then we're going to solve a proportion here. If he went 0.8 kilometers in 8 minutes, how far does he go in an hour? An hour is 60 minutes. And so if you cross multiply here, the 0.8 times the 60 divided by 8 will give you that distance. So there's the calculation, 0.8 kilometers times 60 minutes. Multiply those, divide by this one. We get a distance of 6 kilometers. So this is 100 meters per minute is actually 6 kilometers per hour. So he's probably walking. 6 kilometers per hour actually is a fairly fast walk, but it'd be a really slow run. I guess he could be jogging really slowly, but he's more than likely, if he's going 6 kilometers per hour, he's probably walking here. Now, this speed is twice as fast, so he's actually going 12 kilometers per hour here. So he's probably running. Okay, he's probably running there. So this would be a normal response to C here. So Todd likely ran home from the corner store since he was traveling twice the speed as the first part of his trip. He was probably walking along here and running along here. And that's the end of all the examples. Now, I have uploaded, and you should see links in the description for the video to some practice questions for the linear relations examples here, and also a document that goes over the solutions to them. I hope eventually to have a video that goes over all the video solutions, but there are a lot of them. I haven't made that up yet. I've just done the lessons, but those resources will be available.